All right, we're being asked to simplify this rational expression. This is actually a complex fraction. It's hidden as a complex fraction, though, because of these negative exponents. What we're going to do is take care of these negative exponents. If you've previously learned about negative exponents, you would think about this idea of flipping them from numerator to denominator. The important thing is because we have these additions and subtractions out here, we can't move them from the numerator to the denominator or vice versa of this entire fraction. But what we do is we flip them over within their terms. So here's more of the details on that. First of all, I have this 3 up in the numerator, and then I get this 8 times the x to the negative 1. I'm going to represent the x to the negative 1 part like this, flipping it underneath the 8. And then I do the same thing with the x to the negative 2 here after the 16. I move it underneath the 16 and it becomes an x squared because that was an x to the negative 2. And then I'll just round out the bottom of this fraction in the same way. Alright, so that's just the first initial move. And again, all I've done is taken care of those negative exponents. Now I need to deal with the complex fraction. When dealing with complex fractions, the first real thing I need to do is identify the least common denominator of all of the terms in the numerator and the denominator. In this case, the least common denominator is x squared. And again, another way of thinking about that is just x squared is what I would use as a denominator if I was going to try to add these or add and subtract these all together. And what I do with that x squared, though, is I'm going to multiply each term in the numerator and each term in the denominator by this x squared. I'm not going to take the time to show each of these, and really in the end you want to be able to do this fairly quickly. What happens when we multiply each of these terms by x squared? So I multiply this 3 by x squared, that just gives me 3x squared. Nothing interesting there. When I multiply this x squared times this 8 over x, this x is going to cancel with one of the x's I'm multiplying by, resulting in 8x. Then this x squared multiplies to the 16 over x squared, and these x squareds will cancel, leaving me with just negative 16 here. We'll do the same thing in the denominator, resulting in 3x squared plus 2x minus 8. Now what I'm going to do is factor each of these expressions in the numerator and the denominator. I'm going to act like this is easy to do, and I do it in an instant, but I actually did this a second ago. What I'm going to get up here in the numerator is 3x minus 4 and x plus 4. And the denominator, I get 3x minus 4 times x plus 2. And then I factor them. So in order to find common factors, this 3x minus 4 is a common factor between these two. And what that leaves me with is this x plus 4 over x plus 2, which is my final simplified version. And just to spend a second zooming back and looking at what we did here to remind us of this process, quite a bit went on. But first of all, we dealt with the negative exponents by flipping them over. We didn't flip them from the big numerator to the denominator, but instead within their terms. Then here we have identified the LCD and are now going to multiply by this least common denominator, which gives us the resulting rational expression. And we treat that like we always have. We factor, find common factors, cancel, and we have our simplified expression.